At the end of the previous video, I asked this question: are real numbers complex numbers? And we decided that yes, they are. I think we looked at one that had, maybe it was the number -2, I think. -2 is certainly a real number. It's a number on the number line. But it's also a complex number because it can be written as -2 plus 0i. So to answer this question, I think we know the answer now. Are all real numbers also complex numbers? I'm going to squeeze a yes in there. Here's how you would do it. The number 50 is 50 plus 0i. So every real number is a complex number. Are all complex numbers also real numbers? Absolutely not. Any number that has, let's write down, this is the standard form for a complex number. A and B are both real numbers. If B happens to be a 0, then this is just A, the real number. If B is not 0, then this is absolutely not a real number. So if you see the I, then you know it's a complex number. If it doesn't have an I, it's a real number. But real numbers are complex also. Just use a B equals 0. But complex numbers are not all, it is not the case that all complex numbers are real numbers. Okay, so how do you tell if two complex numbers are equal? Here we go. We have two generic complex numbers, A plus BI, and then C plus DI, which just means that C and D are real numbers, as are A and B. When do you think those would be equal? Well, it turns out, probably like you would expect, the real part has to be the same. A and C have to be equal, as do B and D have to be equal. So these two numbers are equal if and only if A is equal to C and B is equal to D. If one of them differs by even the smallest amount, they are not equal complex numbers. How do we add two complex numbers? I'm sure you'll agree that both of these are written in the correct form. C and D and X and Y are just real numbers. Basically, we handle this just as if I is just a variable. So all these are plus signs, so we could remove all the parentheses. And I want to group the two real numbers together. C plus X, I didn't have to put parentheses around them, but I'm going to. And then I'm going to group DI and YI together. So maybe I'll write it like this first. So hopefully you agree that, we basically use the commutative law and the associative law to go from here to here. I regrouped things. And then I'm going to factor the I out of this. So this is going to become C plus X plus D plus Y times I. And I'm going to go ahead and put parentheses around it just to convince ourselves that this is really in A plus BI form. A, the real part, would be C plus X. This is the real part, like the A in A plus BI, and this would be the imaginary part. I'm just going to put IM for imaginary part. Whatever those two numbers are added together is the real part. Whatever these two numbers added together gives us would be the imaginary part. And then subtracting, very similar. Maybe right above here, I'm going to write A plus BI, and I'm going to distribute the negative sign. So all I did is distribute the negative sign through to make both of these negative. And now let's regroup it. So what would the real part be? Well, it's the two numbers added together that don't have the I associated with them. So it'd be an A and a negative R. So A minus R, that's the real part. And then I could say plus, let's see, BI minus SI. So once again, all we've done is rearrange the terms. We have two negative terms, the r is negative and the si is negative, and then two positive terms with the a and the bi. Now once again, I'm going to factor the I out of this, and I would get a minus r for the real part plus b minus s in parentheses times I. So we've got the real part and we've got the imaginary part, real and imaginary. So again, if we replaced I with just a variable x, that's all we did. We did just basic arithmetic and treated I like it's just a variable. Let's look at a couple of simple arithmetic examples where I'm adding these two numbers together. They're both complex numbers. They're both written in the correct form, a plus bi, a plus bi. Well, I don't think I have to do any work on this one, do I? Do we know what the real part's going to be? Add up the 3 and the 5, and you get an 8. Add up the two the imaginary numbers, the imaginary parts, 2i and negative 7i. 2 minus 7 means minus 5i. So nothing difficult about that. Let's look at the second one. All right, notice that we have two two complex numbers in parentheses with negative signs in front of them. So the first thing I'm going to do is distribute the negative signs through everything and get rid of the parentheses. So I'm going to get 7 I said minus, but it's going to become a plus 9 when we distribute that, and then distribute the negative sign here, negative 2i. So instead of negative and positive, it's positive and negative because we've got the minus in front of it. Minus just changes the signs of what's in the parentheses. So this will become plus 17 plus I. Now let's combine the real parts. Let's see, all the real numbers. Oh, we've got the 9 here too. All right, can we do this in our heads? 7 and 9 is 16. 16 and 17 adds up to 33. And then we have a negative 2i and a plus I. So that's like plus 1i. So it would be minus I. And that's it. So the real part is the number 33. And what would the imaginary part be? Negative 1. This is like plus negative 1 times I. All right, well now we're going to jump into multiplying complex numbers together. And it's actually kind of fun. I think you're going to like this. It's pretty straightforward as well. Here we're multiplying negative 7i times 3i. I mean, you could also think of this as negative 7 times I times 3 times I. So I could rearrange these four numbers. You were treating I like a number. It's a complex number. If I were to rearrange them, I could write it like negative 7 times 3 times I times I. I didn't need to put them all in parentheses, but I went ahead and did that. Well, this is easy. You multiply those two numbers together and you get negative 21. And what do you get when you multiply this two things together? Multiply a number by itself, you get a squared. I squared. You'll never leave an answer like this. Your answers are always going to have only I by itself. But we know what this is. The definition of I says that I squared is negative 1. So this is negative 21 times negative 1, which is a positive 21. So we multiplied two complex numbers together and we got a real number, which makes sense. I mean, I times I is two complex numbers multiplied together, and you get a negative 1 in that case, which is a real number. Okay, next one, we're simply going to distribute. So I'm going to get 3i times 5 plus 3i times negative 4i. So I distributed the 3i. I've got the 3i times 5 and the 3i times negative 4i. And maybe I'll go down below here. Well, this is pretty easy. 3i times 5, you just multiply the numeric parts together. 15i. And similar to the previous problem we did, 3 times negative 4 is negative 12 minus 12i squared, because we have I times I, which is I squared. And this is equal to 15i. Remember, I squared you can replace with its equivalent form, which is negative 1. So all that does is change the sign here. That's negative 1. So instead of minus 12 times negative 1, it becomes plus 12. And the last thing I'm going to do on this problem is put it in the correct form, the a plus bi form. So it's going to be 12 plus 15i. This is the correct answer and written in the correct form. All right, well, the last one we're going to do in this video is now we're going to do a FOIL. We've got 7 minus 5i times negative 2 minus 3i. So we're going to do FOIL. I'm going to write it all out too. F, O, I, and L. Because sometimes it's easy to make mistakes when you do it in your head until you get used to these complex numbers. So the F is going to be what? What is the F in FOIL? It's first times first. 7 times negative 2 is negative 14. How about the outer? The outer is 7 times negative 3i. That'd be a negative 21i. The I is inner, so negative times negative is positive, and it would be 5i times 2 is 10i. Positive 10i. And then last will be this times this. It's negative times negative, so it's going to become positive 15i squared plus 15i squared. Now we need to simplify this and remember what I squared is. I squared is negative 1. So whenever you have something that looks like plus 15i squared, it's going to become minus 15 because I squared is just a negative 1. So let's see, and I'm going to combine these two middle terms. So it looks like negative 14. If we combine these two middle terms, they're like terms. Negative 21 plus 10 is negative 11i. And this is simply minus 15. Remember, I squared is negative 1 by definition. All right, almost done. All I need to do is combine this term and this term. And we get, that'd be what? Negative 29 minus 11i. And that's how we write this product of two complex numbers, how we multiply it out, simplify it, and write it in the correct form a plus bi, where the a, the real part's negative 29, and the b, which is the imaginary part, would be negative 11.